All right, today we're going deep inside the skull to try and understand one of the most complicated and serious injuries anyone can ever have, a severe brain injury. It's a world of incredible forces and often really delayed consequences. We're going to break down exactly what happens when the brain goes through that kind of extreme trauma.
But let's kick things off with a question that's honestly pretty chilling. How is it even possible that someone can take a major hit to the head, seem okay, they're talking, walking around, and then, just hours later, they decline so fast it can be fatal? And this isn't some Hollywood drama. It's a terrifying reality that doctors face. And this is absolutely documented. About 15% of patients who seem fine at first can go through this delayed deterioration. It's such a known phenomenon that it has these really grim nicknames: talk and deteriorate, or, in the worst cases, talk and die. The stakes just could not be any higher. So, to figure out this mystery, here's our game plan. We'll start with the basics. What even is a traumatic brain injury? Then we'll look at the hidden dangers when the brain bleeds. After that, we'll get into the raw power of high-velocity missile injuries, see how they stack up against other penetrating trauma, and finally, look at the crucial steps taken to manage the aftermath.
Okay, let's start at the beginning and lay down a solid foundation. What exactly are we talking about when we use the term traumatic brain injury?
Well, there's a reason the official definition is so broad. A TBI isn't just one thing. It's a whole spectrum of damage that's caused by some kind of external force. That could be a direct blow, the whiplash from a car crash, or, of course, an object actually going into the brain.
And all these injuries really fall into two big buckets. You've got your non-penetrating or closed injuries, where the skull itself stays intact. Think falls, car accidents, that sort of thing. And then you have penetrating injuries, where something physically breaks through the skull. As we're about to see, the outcomes for these two types can be worlds apart. Okay, now let's dive into the world of closed head injuries. This is where things get tricky, because the real danger often isn't the first hit, but the quiet, creeping threat of a brain that's bleeding inside the skull, which is basically a sealed box.
You have to remember, the brain is this incredibly soft, almost gelatin-like organ, and it's just floating inside this hard, bony skull. So when your head gets hit, the brain first slams into the skull right at the point of impact. That's the coup injury. But it doesn't stop there. It then bounces back and slams into the opposite side of the skull. That's the contra-coup injury. And that rebound can be just as bad, if not worse, than the first hit.
And here is what that actually looks like. This is a CT scan showing what's called a hemorrhagic contusion. It's literally a bruise on the brain tissue itself, and these things often pop up right where the brain scrapes against the sharp, bony ridges inside the skull during that sloshing motion. But this is just a single moment in time. The real problem is what can happen next. And right here, this is where we get the answer to that big question from the beginning. That bruise, it's not always a one-and-done kind of thing. It can actually grow. They call it a blossoming contusion, and it is an incredibly dangerous hidden threat. And here's the statistic that explains it all. In up to 75% of cases, these brain bruises get bigger after the initial hit. The bleeding keeps going, the swelling gets worse, and the pressure inside that closed-off skull just keeps rising to dangerous levels. That is why someone can seem fine at first. Their injury is literally getting worse by the hour.
Okay, let's switch gears. We're moving away from that silent, slow-burn threat of a bleed and into the explosive, immediate devastation of penetrating injuries. We'll start with the most destructive of them all, high-velocity missile injuries. Gunshot wounds to the head are the most common type of penetrating brain injury we see, and the stats are just grim. They're responsible for a huge percentage of brain injury deaths in younger people, and to put it bluntly, they are incredibly lethal.
So just how lethal are we talking? Over 90%. The ultimate fatality rate is over 90%. It's truly one of the most devastating injuries the human body can possibly endure.
And to get why, you have to look way beyond just the bullet hole. The real damage isn't the tissue the bullet destroys on its path. That's called the crush cavity. The real killer is the massive energy transfer. It creates a temporary stretch cavity that expands and collapses with explosive force, sending a shockwave ripping through the entire brain. And this slide just shows you the night and day difference velocity mix. On the left, that's a high velocity round. The energy transfer is so huge it creates what's called a blast wound. You get immediate catastrophic swelling that crushes the brainstem, the part that controls breathing and your heartbeat. Now compare that to the lower velocity round on the right. The damage is still terrible, but it's much more localized. It's the difference between a tornado touching down in one spot and a Category 5 hurricane hitting the whole coast.
But not all penetrating injuries are the same. Now we're going to look at a totally different kind of trauma, one that's much more up close and personal, non-missile trauma.
The whole difference really comes down to energy. A bullet has incredible kinetic energy, and that's what creates those devastating shockwaves. But a non-missile object, like a knife or an arrow, it's low velocity, so there's no shockwave, and the damage is pretty much confined to whatever tissue it directly cuts through. It's kind of like the difference between getting hit by a speeding car and getting stabbed with an ice pick. Both are horrific, but the physics of the damage are totally different.
I know these images are dramatic, but they really make the point. This is a knife injury. And as awful as it looks, the primary damage is just along the path that blade took through the skull and into the brain. Same principle here. An arrow with that sharp tip and its low velocity cuts through tissue pretty cleanly. So again, the injury, while absolutely life-threatening, is localized to its direct path. Nothing like that widespread blast effect you get from a high-velocity missile.
So this is one of the most important rules in all of emergency medicine. Why on earth would you not pull the object out? Because that object itself might be acting like a plug, physically stopping a torn blood vessel from bleeding out. If you pull it out in the field, you could cause a fatal hemorrhage. You have to stabilize it and only remove it in an operating room, where surgeons are standing by ready to control the bleeding.
Okay, so we've seen how a head injury that looks minor can turn deadly, and we've looked at the incredible power of both closed and penetrating trauma. So that brings us to the last, and maybe the most important, question. After all this happens, what can actually be done?
Here's the thing. You can't undo the initial impact. That damage is done. The real battle now is against something called secondary injury. The medical team's entire focus shifts to preventing a whole cascade of other problems that can wreck an already vulnerable brain. They're fighting things like a lack of oxygen, low blood pressure, seizures, any of which can make the outcome so much worse. In this race against time, stopping these secondary injuries, that's often the difference between life and death.
Which leaves us with one final thought. We've seen the physics and the devastating results of the initial trauma. But if that first moment of impact is something you just can't change, it makes you wonder, where does the real fight for survival actually begin? Well, the answer seems to be in every single moment that comes after.